At the very top, the inverse of a function is a reflection of a graph over the line y equals x. To graph the inverse of a function, switch the x and y values, also the domain and range. Make sure that you understand that part of it. Because you're switching all the x and y values to get to the inverse, and the domain is the measurement of x and the range is the measurement of y, whatever the domain is of the original function, that will be the range of the inverse. Whatever the range is of the original function, that will be the domain of the inverse. Okay, so make sure that you kind of understand that, switching the x and the y, that's the same as switching your domain and range. Okay, so let's go through this. It says Shannon recorded data comparing a child's age to how far they hit a golf ball. She thinks the distance depends on the age as shown in the table. So we got some lady and a bunch of little kids hitting golf balls. And she's saying, okay, that kid's 3 years old, so I think he's going to hit it about that far. That kid is 7 years old. I think he's going to hit it about that far. So you've got this table. Now, instead of 20, I want you to write 25 right there. Or no, you have 25, don't you? Mm-hmm. Okay, and we're not going to do 6 through 7 because the notes got changed since they were printed off. So just graph 1 through 5 on there for me. And it should look like half of a parabola once you do that. Okay, so we're not going to overcomplicate the domain and range too much here. So the domain of that table is, she's just dealing with kids from 1 to 5. I know yours goes to 7, but we're just going to cut it off at 5. The range is going to be from 1 to 25. And to determine whether or not her graph is a function, you're going to have to think back probably to Algebra 1 days. How are you able to look at a graph and determine whether or not something is a function or not? A lot of people teach it as the pencil test, but what is it called? Vertical line test. So is this graph a function? Yes, because if I do vertical lines, all those are only crossing once. So the only explanation that I need on this, you can just put that it passes, and I wouldn't, feel free to be lazy like me and just put VLT, vertical line test. So the next part of this problem, it says Kenny thinks age depends on the distance of a child, on the distance a child can hit a golf ball. He took Sharon's data, changed it so the x's represents the distance, the y's represent the age, graphed the data on the same grid. So this is how a lot of the inverse situations comes up, especially in real world problems where one person thinks it's one way, the other person thinks it's the other, and there's just a disagreement on what is affecting what. What is the independent, what is the dependent. Okay, so this guy, he thinks that, okay, that kid hit it that far, he's about that age. That kid hit it that far, he's about that age, as opposed to the way the person in the first part had it. So, we'll take what was our y's, the 1, 4, 9, 16, 25, make those the x's, and the age is just going to be 1 through 5. And then you'll graph those points. Like so. And then try looking at that what would be, and also the stuff we already have written on the first part of the problem, what would the domain of this be? Thank you, Trey. Your voice has changed a lot since the last time we've talked. It is. It's all right. So, although I said and make sure you know this, I said your range is now your domain. Don't put y in there because I said your range is now your domain. Okay, it's still the measurement of x, but it's the values that are there. So your range would be 1 to 7. 3 says to graph the line of reflection. Okay, so you can kind of see that it is reflecting across that line. And then it says, what is the relationship between the two situations? And you can just put that they're inverses. So whenever you're done with that, go ahead and flip it over. Now on the first table on the back, because again there's a couple spots on these notes that if we printed off the notes that you have and then the notes got changed. So if you would, right there, yours says distance, mark that out and put time. And right there, yours says time, mark that out and put distance. And you can go ahead and fill in that table. While you're doing that, I'll kind of talk through the problem here. It says the graph shown represents Margot's trip with distance from home in terms of time. Deborah thinks that it should be times in terms of distance. So again, you've got two people who see a situation differently. It's a lot of ways that's how you're going to get the inverse. And then it says plot Deborah's graph in the same coordinate plane. So once you have that, now what was your y or your distance values are going to be your x. What was your time is now going to be your y. And then go ahead and fill those in. And then plot those points. Again, if you're going to label the axis, x and y axis, the increments, I would just do every 5 instead of every single one. If you would as well, go ahead and graph the y equals x line. So the first question asks, is Margot's graph, that's what was on there originally, is Margot's graph a function? Yes or no?
Yes.
Yes, because that black line, I can't draw a vertical line and have it go through there twice. So again, the only explanation that I need on that is passes VLT. VLT. I know it's close to lunchtime, not BLT. VLT. Then it says, is Deborah's a function? No, it is not. So I can draw that line right there. 1, 2, 3. Okay. So we would just put no. Fails. VLT. Now, does Margot's graph pass through the horizontal line test. So, kind of adding something new here, and we'll talk about what that is. It's the same idea, but now if I take Margot's and I draw that line, would it pass the the horizontal line test? No. On question number 10, it says on y'all's notes, if the original graph does not pass the horizontal line test, will its inverse be a function? I want you to put no, and let me kind of explain this. So, if you're asked, and if you know how to use the horizontal line test, then it saves you a lot of time. Because if you're given a graph and then you're asked, is the inverse of this a function? Instead of taking the table, which sometimes you may not even have that, it may just be the graph and you have to make the original table, then you make the inverse table, and then you graph it, and then you do the vertical line test. Instead of doing all of that, you can just do the horizontal line test on the original. And it tells you about the inverse. Okay, so the vertical line test will tell you about the original, okay, whatever graph you're doing it on. The horizontal will tell you about that graph's inverse. Okay, so on 11, it says, what does this mean if the original graph passes through the horizontal line test? So I want you on that one to put, let me read it again so my answer makes sense to what y'all have. It means that the graph's inverse is a function. And then we'll look at that graph down there at the bottom. So on the bottom it asks, does the function in the graph below have an inverse that is a function? Now first, and we'll just say that graph is f of x. Is that graph a function? What is on that? Is that a function?
Yes.
Yes, why?
Because it passes an ELT.
Because it passes the vertical line test. Next, is that graph's inverse, is it a function?
No.
No, why not?
It doesn't pass the horizontal line test.
It does not pass the horizontal line test. I put a horizontal if you just go down the x-axis. So you can just put no, that it fails HLT, horizontal line test. Alright, so let's go to this one right here. So getting into the equation, we've talked about the table, you just switch x and y. We've talked about what it looks like on the graph, it reflects over the y equals x line. Okay, and so now we're going to talk about how it is going to affect, or how we deal with it, just with the equation. Okay, so Ty, will you read that problem for us?
A French exchange student, because Celsius is the temperature scale in France. Jacques uses function C of f equals 5 ninths f minus 32, or C equals 5 ninths f minus 32. To convert Fahrenheit to degrees Celsius, he derived the function from freezing point 32.0 to boiling point 212.100 ordered pair. Yeah. What? Just stop there, or read 13.
Go through.
Do what?
You're killing it, Tom.
Ordered pair is FC, or Fahrenheit Celsius. Okay, so you've got this foreign exchange student, Jacques apparently, came over from France, and he comes over here. Okay, he needs to know how cold it is outside. So he pulls out his iPhone, pulls up the Weather Channel app, and because he's in America and Siri knows exactly where you're at all times, which is scary, knows that he's in America, so it converts it to Fahrenheit, but he doesn't understand, he can't compute that. He grew up knowing Celsius. So he comes up with this equation because he's not smart enough to know that there's probably a setting on the app to change it. So he comes up with this equation where he can take that number, put it into the equation to get Celsius. Okay, now you need to be able to look at an equation and identify what is the independent and the dependent variable. So looking at this equation, what is the independent variable? Fahrenheit. That is what is given. Okay, he looked at the Weather Channel app. It says that degrees in Fahrenheit. So what is the dependent? Celsius. Now, you need to be able to identify that, and y'all are the last class I have to teach the lessons, and it has shocked me how many people cannot identify that. Here is a very, very corny way, but effective way to remember which one is the independent variable. The independent variable is in the equation. Okay? F is in the equation part. C is over here by itself. The independent variable is in the equation.
That actually helps a lot.
Yeah. Okay, so just to kind of help you out there. So on 11 it says to evaluate C of 90. What is that telling us to do?
Plug in 90
Plug in 90 for Fahrenheit. What temperature is it in Celsius if Fahrenheit is 90? Okay, so Chance, will you please plug in 90 in for F? And tell us what you get. Okay, so whenever you plug 90 in for F, you should get roughly 32.2.
Mind you, was a fraction.
Okay, and so what that means is
Degrees.
whenever it is 90 degrees Fahrenheit, it is 32.2 degrees Celsius. Okay. So on the next part, we're going to write a function that will give an output of Fahrenheit when using an input of degrees Celsius. Now, this problem, we've used this problem for many years now to explain this, but we've kind of taken out another story part of it that I think helps. Just kind of get an understanding as to why this would happen. So, let's say that Jock wants to, he's going back home, and he decides to take Ty with him back over to France so that Ty can, look really smart calling all the jocks over there Jacquez's. So he takes Ty over there with him. Ty goes over there, he pulls, he needs to check the temperature, so he pulls his phone out. Since Siri is creepy, she knows he's in France, so it has it in Celsius. So he has to come up with an equation that given Celsius, he knows what temperature it is in Fahrenheit. So what is the independent variable in that situation? What is given to him? Celsius. And what is he trying to find? Fahrenheit. Okay. How are these situations related? Let's see. They're going to be inverses. They're inverses. Any time where you're flipping the what I call flipping the dependency. Okay. That means you're just switching which one is independent, which one is dependent. That's an inverse situation. So now we need to write the function for the new situation. So we did have the equation that we did use previously with C equals 5 over 9 times F minus 32. And this is when we're going to use SADMAP. Okay. And all we're going to do here is we're going to do SADMAP and solve for F. So first, is there anything I can subtract or add to the other side? Can't do 32 because it's in parentheses right now. Okay, if it would have to be something at the end, something out there that I would add or subtract. Can I multiply or divide by anything? Okay, I can divide by 5/9, but I don't like to divide by fractions because it looks weird.
Multiply by inverse.
Multiply by its reciprocal. So I can multiply both sides by 9 over 5. So I've got 9/5 C equals F minus 32. Is there any exponent in here that I have to deal with? Yes or no? No. And then usually what that will mean, even if I do have to deal with an exponent, if there's anything left to do, it's going to be inside a set of parentheses. And so once you deal with that, now you just start over. I've got minus 32. So I can add 32, and I end up with, I'll just add it over, put it over here underneath 14. F of C equals 9/5 C plus 32. Okay. And Marshall, will you do F of 32.2 into that equation? So you're just plugging 32.2 in for C. But somebody tell me before he says that answer, what that answer should be roughly what number? 90. Because whenever we plug 90 into the other one, we got about 32.2. Chance rounded it. So this won't be exact, but what was it? 89.96. Okay. Now, going to the next part, which is the back, if I had to put a number to it, I'd say that in the past, probably about half of my students have made this mistake and have trouble grasping this. If it is a word problem, okay, well, first let's talk back to the warm-up. Whenever we had the warm-up and we had that equation y equals 2x plus 4, and we found the inverse to be whatever it was, x plus 4 over 2, what was the first thing we did? Did at the beginning of class. Do what? Even before that. Even before moving all the stuff around. What did we do?
We do what?
Do what? Someone said something.
All the points.
No? Well, we wrote the equation, but then what did we do with the equation before we actually started to do that? What did we do with x and y? Flipped it. Flipped x and y. Okay? Whenever we started this process, did we flip C and F? Yes or no? We did? So I just wrote that equation and then we started to solve for F. We didn't. If it is a word problem, do not flip the variables. Okay? If it is a y-x problem, flip y and x. Okay? I won't. If you want to, if you want me to explain why later, I will. You can come in one-on-one, but I've tried explaining that and I feel like I've lost more people than I've gained going through that explanation. But I will be more than happy to explain it to you one-on-one. Why you don't flip it on word problems and why you do whenever it's y and x. Okay, but you need to get in that habit of knowing that. So let's go to the back. Now there's two methods. I'm really only going to do method A. I'm going to do method B for the first one, but then we're just going to do these three for method A and then we'll be done. So, starting on 16 there. First thing I need to do, I need to remember f of x is just a fancy way of writing y. So make sure that you're using y instead of f of x. It just makes it all look better. After that, I'm going to switch x and y. And then I'll solve for y. Okay, so Andy, if I'm solving for y, what would be the first thing I would need to do there? Subtract 2. Carrie, what would I need to do to get that 3 off of there?
Divide all of them by 3.
Divide both sides by 3. So the inverse of f of x is equal to x minus 2 over 3. Okay, going to method B. The only difference between method A and method B is we switch x and y at the end. Everything else is the same. Alright, if you like doing method B over method A, that's fine. I do not care, as long as you get the right answer. So I'm going to go through it, but this will be the only one that I go through both methods on. So I don't switch them, I just go ahead and start solving for x. And all the steps are the same. I'm going to subtract 2. I'm going to divide by 3. And I get the exact same answer. And I'll switch it at the end. So I still need to write it as x minus 2. Never, ever, ever write an equation as x equals y minus 2 over 3 as your final answer. Okay? So, let's go down to 17. Again, I'm going to make sure that I'm using y instead of f of x. I will switch x and y. So on this one, what is the first thing I would need to do?
Add. Oh.
So if I have to add, if I'm going to add, it would need to be something out here. Okay. Whenever you're going through the SAD map, the square root is going to fall underneath exponents. Okay. Either you're getting rid of an exponent or you got to use an exponent to get rid of it. So Marshall, what is the opposite of square root? The square. So because that minus 4 is inside, I've got to get rid of that radical before I can add 4. So now that radical is off, and then I would add 4. So y equals x squared plus 4, sorry. And so that would be the inverse. Now, if this problem was this, the first thing I would do is add 4, because it's outside the radical. So, you know, I bring up the PEMDAS SADMEP thing because the order does matter. Alright, so let's go to 18. First thing I'm going to do here, I'm just going to go ahead and flip them. I'm not going to write this equation 3 times before I get started on it. So to start off, is there anything I can add or subtract?
Yeah.
I can subtract 4. Multiply or divide? No. There would need to be a number like right here. So if there's like a 3 there, I would need to divide by 3 first. Which there's not, so I don't have to do anything for that one. How do I deal with the exponent? Square root it. So I have the square root of x minus 4. Now I'm inside the set of parentheses, so I start back over. And what's the last thing I need to do? Add 2. So somebody tell me what is wrong with this.
Because you're not adding two to like what's inside, you're adding two to the entire thing. So if you leave that way, you're adding two just for example. I don't know, that makes sense in my head.
No, I'm following you. I don't know if everybody else was.
No. That was
Yeah.
really
It's
smart
like,
talk.
it's all
I'm sorry,
good.
so it's like, if you were to add two to, like,
Okay, so that's how it should be written without the radical over the +2. One way to denote what you want underneath the radical is putting those parentheses right there.